Hello, welcome to Longevity Industries' presentation of the Destiny of Manufacturing podcast. Special thanks to our sponsors, localenterprise.com, that's enterprise with a Z, home of the CodyBot, the robot for sanitizing, disinfecting, and temperature measurement for your employees. Definitely needed here in the time of COVID as we're trying to get out of that a little bit. I also want to thank the Precision Metal Forming Association, the PMA's Educational Foundation, for helping to put this show together. I have with me today, with a loud round of applause as he comes to the front entryway of the ring, Eric Kam. Welcome, Eric.
Thank you, Dean. I didn't know that I had to organize my entry music with you. I would have picked something, a little bit more befitting my own style and idiom.
There you go. Eric, of course, is from ESI-Group, where he is the industry marketing manager and formerly known as the self-proclaimed die expert. Is that what we want to go with?
Yeah.
All right. So right off the bat, Eric, tell us what you see 5 years from now.
What I see 5 years from now. I when you mentioned that as one of the things to want to talk about, that put me a little bit off balance, because I was thinking to myself, if you had asked me a year and a half ago to chart out where we would be 5 years from now, right now, I'd already know, only a year and a half into that last 5-year projection, I'd be totally off, because to mention a completely overused term lately, all of the pivoting and all of the modifications and accelerations to people's business plans and ambitions for digital transformation and digitalization of manufacturing and manufacturing engineering, pretty much everything that I thought was realistic a year and a half ago, some of those things that I thought were, too far beyond and not attainable, a lot of that stuff is happening all day, every day right now. And the things that I would have thought were most attainable in, 1.5 to 2 years from an earlier projection, probably those things have been, sidelined and set aside for these new initiatives. So, right now, my 5-year vision, as far as clarity, my crystal ball is telling me that we're just going to be seeing a lot more of this acceleration. I don't even want to call it a pivot, because we were already heading in the direction of digitalization and digital transformation. And I've been talking about going to fully virtual validation of manufacturing processes, fully virtual validation of the engineering design in context of manufacturing processes. And that's been a drum that I've been beating on for some 25 years that I've been, in industry. And, that was a steady beat, and it felt like we were getting closer, but not really getting there. And now all of a sudden in the past year, because of the situation, we've really accelerated a lot of stuff that I would have thought was just having too much organizational inertia to really happen. And now a lot of that stuff's happening. So right now, I guess I would say, the 5-year outlook, we're going to keep seeing this acceleration to fully virtual, fully digital validation of product design and of processes as well. And that's one of the key things that I see, is that we're now expanding beyond just the pure digital validation of product data and product design input, but also reaching towards this procedural and process planning things that are not so easily captured in traditional deterministic and computer-aided design tools.
I think that you're spot on. We have accelerated the direction we were already going in. I think that's, and it's been good. Surprising is the word I would use. It surprised me that if you asked me 2 years ago, will this be done or could it be done? I would say it could be, but it won't be, because I felt like too many people would have to be involved and make that decision, that they all wanted to pull the rope in the same direction. And that was not going to happen. But surprisingly enough, we did. Do you think
Go
ahead, sorry.
I was just going to double down on what you were just saying, is that, a lot of the things that would have been nice to work to as far as digitalization and digital transformation, and they were kind of like the stretch goals that we would have thought were stretches a year and a half ago, those became absolute necessities last spring. And I was just myself reflecting on my own journey as I shifted from being that self-proclaimed die expert and started working more in extended realities. What I've been working in with virtual reality with ICI-Do at ESI-Group is that when I joined the company, it was radical that an engineer could fill out a form and ask for a virtual reality headset, the same way you and I would say, I need a mouse for my computer. And that was only in 2016 and 2017. And nowadays, it's becoming more commonplace that people are being issued VR and XR gear the same way you or I would just ask for a monitor or a keypad or a mouse pad. And it's just part of doing business. And that's been really radical, how much that's changed in such a very short amount of time.
Yeah, it really is. I would have never thought we would have gotten to that point that quick, especially with some of the delays that we'd had going up to it, which is everybody knew the technology had merit. Everybody knew that there was a value in both augmented reality and virtual reality, but how do we execute it? And do you think that the programming was one of the factors that kind of slowed things down, that people were waiting for more programming on that to really explode, and then they were going to jump on board later, and since they didn't really see it happening in front of their faces, they kind of assumed it wasn't happening?
That might be one of the background causes, but one of the sources of friction in the implementation of more virtual engineering technologies that I have seen is that the biggest competitor to digitalized engineering and virtual engineering has been the fact that the biggest competition is the status quo. And the status quo was, for most of this kind of engineering that I've been validating with virtual reality, was that there was a physical pilot plant, and it was part of the engineering process that you would fly to the supplier's site to see that new equipment or that new machinery that you are commissioning for installation in your manufacturing environment, and that it was everyday business. We would get on an airplane or get in our car and we'd go to the supplier, and to see what that new hardware was going to be like physically in person, and we would do the walk around, we would do the kind of ergonomics, human factors, space claim kind of analysis. We would do it physically by working with that product. And one of the things that was keeping people from going full digital was that every time we mentioned you could do this in VR, it was a parallel task, that there's already a milestone in the engineering budget that says we're going to have a face-to-face in-person inspection of the hardware at month X of that particular development process. And that when we introduced the idea of doing that virtually, then people were like, oh, that's an extra step in addition to the physical step. And they didn't have the confidence to eliminate that physical step. But when the physical access to that pre-production tooling or that pre-finalization acceptance of that commissioned hardware, when that was taken away because of the situation that we are starting to emerge from regarding confinement and work from home, is that now when I said, let's do it in VR, people weren't thinking that that was a running alongside or a duplicate process to what they were going to do anyway. It was now the only way that they could have moved forward with their project. And so a lot of that has just like loosened up the previous inertia, I would describe it as, that people were just clinging to that inertia of this is the way it's been and this is how our process is defined. And once we took that process away because of the necessity of COVID-19, now it became far more realistic. We're going to do it in VR. And people were a lot more accepting of that. So I think it just, changed people's mindset a bit.
Yeah, I like the way you illustrated that, because that's what I saw. This was kind of a disruptor strategy in that you have a timeline going along, and they already had preconceived ideas of how those steps were going to go. And when you took an eraser and marked off that this was not possible anymore, then there was this moment of, okay, now what do we do? And that was a big solution, was we can use VR. We can use AR to get us where we want to go. It was the solution to get around a problem that otherwise we probably wouldn't be talking about that as much as we are now. Unfortunately, people were too locked into a step that they already had in their process. Now,
Exactly.
Yeah. Now, do you see in your crystal ball, if you get out Eric's crystal ball and check in there, do you see a point here in the 5-year picture where not only is this going to be adopted, but commonplace?
Absolutely. Within the next 5 years, we will have to expend even more energy trying to explain to incoming engineers as we're onboarding them. We'll have to explain to them that the thing that we're doing right now, we used to do in person. And Grandpa Dean and Grandpa Eric, who are now, the old dudes walking around the manufactory, are going to have to explain to people, like, back in the old days, we used to drive to the plant to inspect what the tools were going to look like if they shipped the tools to my home plant. And that was the only way we could inspect them. Or I remember doing very early, the first time I was doing transfer automation reviews, I remember going to the pattern shop and standing there with the full polystyrene pattern for a large automotive stamping die. And it was the draw die and the trim die. And we had this giant piece of cardboard that we had cut out to match it was a tri-axis transfer press. So we were mapping the tri-axis transfer press's path with this big cardboard. It looked like the curvy brackets on your keyboard, and you would hold that thing over the tool, center line to center line of the draw die to the trim die, and that's how we would look to see if there were interferences that would clash with the automation in the tri-axis transfer press with the casting. And that was the only way that we could convince people that the castings were good enough to pour. And this was still within the past, I'd say maybe that was 10, 12 years ago. And that was state of the art, is that we were standing there with a cardboard template, a piece of string stretched between the cardboard cutout and the styrofoam patterns. And we were doing this automation collision check. And nowadays, the technology existed to do that virtually back then, but we didn't have that trust. And nowadays, if I explain that physical process to an up-and-coming engineer and, whoever the next generation of self-proclaimed die experts are, they're going to say, how on earth did they have more digital trust than the digital version, than the virtual version? And I'll have to shrug my shoulders and say, that's just the way we did it.
Yeah. And there was just a level of acceptance that we had within that. And it was fine, I guess, for that time frame and to say it, but it was time then to move on, and it definitely is past that now. I was reading, there's a study by CGS that talks about augmented reality, and they say that 61% of the operations leaders plan to invest in augmented reality by the end of 2021. I was blown away by that number, but not that surprised, because I think you illustrated it perfectly, that what's happening is that people have to move to a different solution. Do you think that we'll get there to as far as 61%, or is that number a little bit beyond our grasp?
That feels a little bit ambitious. maybe 61% of people will make an investment in augmented reality, but whether or not that's a significant investment or not is still yet to be seen. Because, I mean, from my point of view, and I'm working in the XR space, and I see a lot of times people are applying virtual reality, augmented reality, expanded reality to problems where I still shrug my shoulders and I ask them, so what is the absence of value that we're really resolving by doing this in VR as opposed to just on my flat two-dimensional screen or with a keyboard and mouse? Why do I have to do this in VR? And we still see that happening with augmented reality where people are saying, hey, let's give everybody, a Microsoft HoloLens so that they can see the virtual reality or augmented reality version of your typical kind of production scoreboard. And I'm like, well, why is that better than just putting up the big TVs at the end of the line that just gives that output, on the TV? And so there are these places where I've seen people investing in extended reality technology where it's a gadget, it's a gizmo, and it's something cool for, whatever plant manager or whatever technology evangelist inside of a company to hang his hat on and say, we implemented AR, but we implemented AR to resolve something that wasn't even a problem. But the old way of just putting those old production, those Kanban boards up in your plant, why is an augmented reality Kanban board better than a real one? I don't get it. And so
Right.
in some terms, I see there's lots of investment opportunity, and I see a lot of people are making their initial investment. But I also fear too that sometimes people are, they have a solution looking for a problem to solve.
Right. And that there may be some of that, I think, that goes on. I think that some people like the fact that I can bring something that's not here into here. They like the idea of being able to bring a city inside of a building through virtual reality.
Yep.
And they like to be able to, well, frankly, one of the areas that I've seen really taking off, and I was talking to somebody from Purdue University, my guest Chandramali, he was telling me about one of the projects he's working on, which is to use it for safety. So when you're doing training on the plant floors and you're doing work like that throughout the factory, that rather than having to shut down a machine to do training on, they can do it virtually. It also reduces, obviously, the amount of risk. Since you and I have both been in plants many times, you know how loud it is, you know how busy it is, and just that alone can be very distracting to a new employee.
Absolutely. Yeah. One of the things that when it comes to like and my focus is I'm always going to kind of go back to the manufacturing engineering thing as opposed to the manufacturing execution part, like you just described with safety training. But like when we're doing human factors and ergonomic safety evaluations for some of our customers, and we're doing that in virtual reality, that the scenarios that we're evaluating are scenarios where if we didn't have virtual reality to validate, is this ergonomically and human factors safe to even try to accomplish what we're going to do in this particular engineering review, we would have to put a human being in harm's way at that pilot plant or at the physical mock-up to see if this is dangerous. And so, imagine, if we were doing some sort of, someone's designing a new stamping press or someone's designing some new equipment that's going to go into a manufacturing environment, and they propose its design. And if we have to evaluate how safe that design is using the old school methods of, do so much evaluation on a flat, 2D planar screen, and then eventually build a physical mock-up of that, and then walk up to it and do the final validation of our engineering assumption, we would be doing something that ultimately we might decide is dangerous or hazardous. Mm-hmm. And doing it to prove that this is or is not a safe design. And there's so many things that now we can evaluate that would have been either accidentally greenwashed by not being evaluated early on, or they would have been just like people wouldn't even known to look. Like, is that going to be a problem? Sometimes when we're doing these VR reviews, we see things that were not on our punch list of, be sure to check the clearance and the headroom inside of the space. Sometimes those things weren't part of our checklist, but as soon as we were in VR and the brain tells me that when I'm in VR that I'm standing right there in the room next to that real equipment and not in my dining room, standing in front of my dining room table, that I'm able to say, hey, I didn't see that before, but that looks like kind of a dangerous pinch point. And if I'm able to do that in an engineering review with my colleague who maybe is in his own home office, or maybe he is, a country away or even an ocean away in one of our other facilities, that I can both teleport each of us into that virtual future plant. And we can see something that we didn't even know was a potential issue. And when we both see it, we can both experience that in virtuality. We added a new item to our little checklist, our punch list of issues to look for. And that often didn't happen until, in normal engineering, the two of us would have been in that plant or at the supplier site inspecting the new equipment coming in. Then maybe we would have seen it. So a lot of that's been, very enlightening and a lot of fun, actually, for the past year, is that, I've been doing these VR reviews that they're not just teleportation, but in a way they're time travel, because that plant, had I not just been doing it in VR digitally, no way it would have been ready for another couple months or even maybe half a year for me to be able to physically stand in front of that. So I am kind of traveling into the future in addition to traveling great distances around the world, or maybe just on the street to my colleague who's also working from home.
Yeah. Yeah. I think that's a very good point of how you execute things. I was involved with the Michigan Safety Conference up there, which is happening again, I guess, now it's this month, at least at the time when I'm speaking here in April. That's when it is. But the experience that I ran into at the last year's one was that there's a number of insurance people, and I was blown away at how many shown up at this type of an event. And according to them, part of it is what you already have seen deployed, which is on your smartphone, measuring your speed, measuring how quickly you change lanes. So safe driver discounts, so to speak. And now with the VR and AR, they're looking at the same kinds of things, at assessing plants based on their utilization of these tools that reduce risk, which is how I look at augmented reality and virtual reality. Is you are reducing the amount of exposure to risk because you're not out there on the plant floor for all of your training. So if I can have somebody there that doesn't have to go out on the floor, or if they do go on the floor, they're wearing glasses and it illustrates where there's a hazard. Do you think that that's more of the direction that companies are going to go in with this utilization, or is it more just as a production tool?
I see it going into, not one or the other. It's going to be different flavors of all those potential directions. When we think about the risk that we're addressing by doing more of this extended reality, supporting these extended reality workflows, whether it's a virtual reality validation of the commissioning of a new product or a new piece of equipment that's coming into your line, if it's onboarding new manufacturing personnel as they're getting introduced to a new piece of equipment in that plant, and also when that plant is maybe considering doing kind of like lean workshops in order to improve their overall productivity, there's risk to human safety. There's risk to the multi-million-dollar product or the multi-million-dollar manufacturing hardware that we're considering running these workshops on. And there's, of course, the risk to making a decision that is ill-informed, or the risk that comes from not deciding, right? That not changing something that could be changed is a different decision. It's a decision to stay still. And I was talking to a plant manager of one of our customers, and we were talking about using our virtual reality solution to validate the incoming manufacturing cells, right? And he mentioned that it's not only about the new plant launch and the introduction of new hardware, but he really saw opportunity for when they're doing these kind of production improvements. And that he saw that in his own experience, and this was a guy from an automotive OEM, large European automotive OEM, and he was running an entire general assembly and final trim line. And he mentioned that there might be multi-million-dollar a month savings that somebody pointed out to him that said, if you could fix this one particular manufacturing cell and address the human factors or address that ergonomics problem, you might be able to eliminate, $1 million worth of downtime that happens to you every month or every week. And he has to leave those production improvements sometimes untested and not implemented, because for him to just shut the line down to do the kind of lean workshop that would help you understand if that production change was going to pay off, that would mean that he'd have to schedule a weekend of overtime for his machine repairman to come in and set the line up with this alternative configuration, that he would have to schedule overtime to do a production run ahead in the odd chance or the highly potential chance that when they're testing this production improvement, that they lose their production volume. So he would have to schedule, additional overtime to run ahead, additional overtime to change the line over. He would have to schedule that the line might be at sub-capacity for a full week until he could go to the next weekend to maybe undo if this was a bad idea to try to implement this production improvement. And he's like, yeah, most of the time we do like 10,000, 20,000 euro cost improvement. Those are the things we implement, but we don't get to implement the multi-million, tens of million dollar cost savings because we expose the whole production environment, not just the workers, but the workers, the plants, the product coming off the line, all became at risk while he tried to evaluate whether that production change could happen. And so I see this impacting many different forms of the risk that manufacturing faces. They're facing risk with their human resource personnel, they're facing risk with their production hardware, and they're facing risk with their end product, the thing that they're supposed to deliver to keep the lights on at that facility.
Yeah. I think that's an unbelievably perfect illustration of some of the problems that these people in factories are faced with, is that how do I prove out that this idea works when if it doesn't work, you're probably going to get fired. When you cost your company millions of dollars, you don't run into that situation like GE and Jack Welch, where I just invested this much money in you. That doesn't happen that often. More often than not, is you just cost the company millions of dollars, get your stuff out of your desk and probably head home.
Yeah, that would be a hard one. And, by being able to do so many more of these production improvement evaluations, whether it's production improvement of current product, or maybe it's a production improvement for something that's going to land in your facility in the next year or 2 years from now, being able to evaluate that in I'll call it the sandbox environment of a fully virtualized version of your product in a digital version of your future plant. And then we just asked you, Dean, to put on your head-mounted display, your VR headset, or I put on my augmented reality glasses, and I'm able to perform and experience what my product would be like in that manufacturing process and see what it's like for me and you as individual people to experience that in advance. That really fixes the whole it's better to ask forgiveness than to ask permission kind of thing.
Sure.
We can just do these evaluations and we can prove it to, the boss, to the plant manager, that we say, yeah, shutting the line down, for the week so that we can implement this. Boss, we validated it. Here, let's go put on the VR glasses, right? Or let's do VR between myself here in Detroit with Dean down in Tennessee, and let's just see what it's like and prove to you that we can ship that equipment from point A to point B and install it and feel confident that it's going to work.
Mm-hmm. Yeah, and I think that's the word to use too. Is it provides confidence. It gives you this feedback to say, yes, this is achievable, and we can do this. Whereas without that, even without simulations or other forms of confirmation, it's difficult. And I can tell you, just on the IoT side of it, I've been in plants before that use, it's not simulation, but actually running and making a change. Now, IoT side, I can actually measure the results of what happened. Now, it costs money to do that, though. The one example I'll use is that a plant they would have to shut another machine down in order to make a tool change on the other machine because they were right across the aisle from each other. Well, everybody knew this problem and wouldn't do anything about it till the IoT side of having LinkNet in there illustrated the problem that, hey, you're losing all this money by shutting down one machine or the other every time you make a half-hour tool change. Not a good thing. And everybody knew this for years, but it wasn't until they had the numbers in front of them that they would make the change. What are your thoughts on that?
I'm glad that you brought that up. One of the things that when it comes to implementing IoT, right? And I'm gonna shift gears now. I've been focused so much on virtuality, but let's think about the idea of virtual or synthetic data just as a whole. And one of the challenges that we've seen when we talk to our customers about doing IoT and using that to control their processes and to recognize when their processes are in control, is that one of the risks that exists in IoT implementation is that we don't always have the data of the failure mode or of a safe failure mode already existing in our IoT data. And that one of the guys that I work with, Dr. Cianesta, who's the chairman of our scientific committee, he always talks about that there's this thing called ignorance when you think about a data set. And that when one of the things that happens with pure IIoT data is that your response surface, the surface or the volume of data that you collect, always has to be coming from a real measurement on a real machine, on a real device, which in order to, really inform this production control system based purely on IIoT means that, well, we can keep the machine from breaking because we know what broke the machine last time and we have the data on it. But that sometimes when you're trying to control a process and you're using this sensor data and you're trying to build up that backbone of decision informing data in your IoT, is that if you haven't recorded or got the data from catastrophic failure, then it's nearly impossible for your IIoT machine learning artificial intelligence algorithms to project or to interpolate. Am I saying the right word? Interpolate is when you look at extrapolate, to extrapolate out data that didn't exist before. And one of the things that we've been doing, not just in virtuality, but think about the virtual or synthetic data that could be generated if, in fact, you had a really well-designed digital twin of your production tooling or the material that you're commissioning, is that in a virtual environment, I can induce absolutely terrible, bad idea machine settings in a safe from personnel point of view, but also safe from production and equipment. I can induce these terribly bad situations. And if I have my digital twin actually well engineered so that it is a good reflection of your physical object and the way its sensors are set up, that we can now create this idea of a hybridized digital twin, which is being partially informed by synthetic or virtual data that we're using computer-aided engineering or finite element analysis or model-based systems design kind of emulations. And we can also have some data from the real world kind of all mixed in together so that we get a much broader picture of the situations and the scenarios in which failure could happen in this equipment. And that's a really kind of, that's something that, again, a year and a half ago, I would have said it's our stretch goal that in the next 5 years, people are going to be doing these hybridized twins where IIoT and synthetic or simulated data are going to be commingled in a way so that these digital twins don't have problems extrapolating out unrecorded situations or incorrectly interpolating for data that's not filled in the in-between spaces between individual data points. And that's something that we're seeing, again, because of the rapid acceleration of digitalization that we've seen in this past calendar year, is really something that I would have said maybe in 5 years we'll be there. And now maybe my crystal ball is telling me it could happen in the next 2 or 3 years, where this idea of having, really realistic virtual digital twins that are hybrids between real world measurements, but are also filling in the gaps of the real world measurements by, doing this kind of synthesis, doing this digitalization, virtualization of our manufacturing environment, so that we can get this full data set of more than a lifetime's worth of real data, as opposed to the challenges we face right now with IIoT, is that the real production gains and being able to predict the real problems, you're not going to get those in the first couple weeks that you have, your whole link net set up and cataloging that data. It's like, yeah, we got to break the line a couple more times. We have to have a few more failures just to even know what data shows up when the line's not working well. But the line's working well right now, so our data is, pretty trivial.
Yeah. I think that's the value-added portion of using virtual and augmented reality is there's something beyond just getting data. It's all the little things, like you mentioned, that happen when you're doing this. It's all the little hidden pieces that come to light when you're like, oh, geez, I would have never thought that was going to be a problem. But now I could see that this is in the way over here. This isn't going to work here. All those things that are trial and error, usually when you actually draw something on a picture, on a line. I could tell you from going through many plant layouts experiences, it doesn't always work where you drew it on the floor.
Yep. And the key word that you just said there is experiences, right? And for me, this whole idea of building up and reinforcing our engineering confidence, our manufacturing confidence, the key word there is experience. And we can throw data on that, right? And we can keep throwing a lot of information and a lot of knowledge and a lot of data at problems. And many times that still doesn't really improve people's confidence. And that most of the time, and when you talk to people about, when they've had this kind of breakthrough moment, like, I didn't believe in, that this was going to happen until I experienced it myself. it's all about that own experience.
Mm-hmm.
And anything that we can do that injects that idea of, I got to experience what the future production of this future product might be in the future plant, and I experienced it. Yep. Versus I saw somebody do a puppet show on screen, or I saw a kind of a keyframe animation on screen. As soon as I experience, my confidence probably magnifies, by a whole degree of magnitude. We just see a much deeper appreciation for engineering decisions and engineering confidence when it's informed by an experience, as opposed to, it's something I saw on screen once or twice.
Right. And speaking of experience, tell everybody where they can find you, Eric.
Where they can find me, I am with ESI-Group. That is ESI-Group.com. And I work with a software solution that we call ICI-Do, which is used to help people inform their human-centric product and process decisions.
Very good. It was great to have you here today, Eric. Everybody go out and make it a great day.